Hello students, welcome to the class. So we started with motion in a straight line. In motion in a straight line, we have discussed what is motion, types of motion, then the terms related to motion, what is the difference between scalar quantity, vector quantity, distance displacement, speed and velocity, then types of speed, types of velocity. These all concepts we have already discussed. Okay. So in the today's class, let us see the next point, that is acceleration. So here, what do you mean by acceleration? Then what are the types of acceleration? Let us discuss. Assume that suppose a body is moving. If you assume consider a body of mass m is moving with the initial velocity u and final velocity v, okay, in the time interval of t. So here, when you consider the initial velocity as u and the final velocity as v, how can you write the change in velocity? Change in velocity, how we write? Change in any quantity is written as final minus initial, that is v minus u. Here, acceleration is denoted by a. This acceleration is defined as rate of change of velocity. Acceleration is defined as rate of change of velocity. So change of velocity, I have written it as v minus u divided by t. So this is called as what? Acceleration. This is called as acceleration. So let us see the unit of this acceleration. How we write for velocity? Velocity we write it as meter per second divided by time is written as second. Therefore, this is nothing but meter per second square. This is nothing but meter per second square. That is the unit of acceleration. The unit of acceleration is given by meter per second square. Then the dimensional formula written as. So velocity dimensional formula is L t raised to minus 1 divided by t. Therefore, this can be written as m L raised to 1 t raised to minus 2. So this is the dimensional formula for acceleration. This is the dimensional formula for acceleration here. Suppose if the acceleration is increasing, means if the initial, suppose if you take the example, if the initial velocity is 2 meter per second and the final velocity is 1 meter per second. Can you see here the velocity is decreasing from initial to final, right? So if I take the change in velocity for this, what we will get? Change in velocity is written as v minus u. So v, how much I said? It is 1 minus final initial is 2, that is nothing but minus 1. So minus 1 is the change in velocity. You can see here the acceleration, you are getting it as minus. So when the acceleration is decreasing, when the acceleration is means velocity is decreasing, this acceleration will be negative. So the negative acceleration is called as deceleration. Okay, it is called as deceleration, or we also call it as retardation. We also call it as retardation. So acceleration, when it is negative, then it is called as deceleration, or it is also called as retardation, which means that the velocity of the body is decreasing. Velocity of the body is decreasing with time. Okay, so this is the expression, and here is the SI unit and dimensional formula. Then the types of acceleration also we can take 4 types here. That is uniform acceleration, non-uniform acceleration, average acceleration, and instantaneous acceleration. So uniform and non-uniform, it is similar to your uniform velocity and non-uniform velocity. Here average acceleration, the definition is given by the average acceleration over a time interval is defined as the change of velocity divided by time interval. So average acceleration is nothing but what? It is the total acceleration, or we can say it as the total change in the velocity divided by total time taken will give you average acceleration. Is it clear? So average acceleration, you can see the expression, it is given by, here it should be divided, okay? The expression for average acceleration is, this is A is equal to V2 minus V1 divided by T2 minus T1. It is V2 minus V1 divided by T2 minus T1 is the expression for average velocity. Sorry, average acceleration, where v1, v2 are what? Change in velocity, and t1, t2 are what? Change in the time. Okay, so this is regarding the acceleration concept. Then next, so instantaneous acceleration. Instantaneous acceleration is defined in the same way as that of what? Instantaneous velocity. So how we define instantaneous velocity? At that instant of time, what is the velocity of the body is taken as instantaneous velocity. Similarly, instantaneous acceleration is, it is in that interval of time, what is the acceleration of the body, that is called as instantaneous acceleration. So this instantaneous acceleration is given by limit of v divided by t. Here we write it as that is instantaneous acceleration limit t tends to 0 v divided by t. So this can be written as dv divided by dt. This is nothing but instantaneous acceleration. Here you can see as the t tends to 0. So this shows that it is the instantaneous acceleration. Means in that instant of time, what is the acceleration of the body? So dimensional formula for instantaneous acceleration or acceleration, it is same. It is m raised to 0, l raised to 1, t raised to minus 2. And the unit is meter per second square. Okay, so here when the acceleration is uniform, the instantaneous acceleration equals the average over that period. Means when we say that acceleration is uniform, here the instantaneous acceleration will be equal. Okay, since velocity is a quantity having both magnitude and direction, a change in velocity may involve either or both of these factors. Means what is the meaning of this statement? That is, here as the velocity deals with magnitude and direction both, we say that acceleration is also same. That is, it is also magnitude, which shows magnitude as well as direction of the body. Therefore, this is called as what? Vector quantity. This is also called as what? Vector quantity. Acceleration is also a vector quantity. So this is regarding acceleration. So what do you mean by acceleration? The rate of change of the rate of change of velocity is called as acceleration. The unit is meter per second square, and dimensional formula is m raised to 0, l raised to 1, t raised to minus 2. Then the types of acceleration we discussed. And let us see the next one. Acceleration is therefore may result from a change in the speed, or we can say that it is change in magnitude and direction both. Okay. So as we say, the acceleration velocity may positive, it may be negative, it may be 0. In the same way, acceleration is also positive, negative, and 0. Positive, negative, and 0 it is. Okay. Then next we have equation of motion in a straight line. So before going for equation of motion of a straight line, here just few diagrams we will see, that is VT graph. What is VT graph? What is displacement time graph? Let us discuss that. Here acceleration is nothing but rate of change of velocity. Okay. So first let us see velocity time graph. So I'll show you some diagrams here. That is velocity time graph. Velocity time graph in the sense the velocity will be along y-axis and the time will be along x-axis. So if a body is moving with uniform positive acceleration, the figure or the diagram will be like this. So you may get one question based on this nature of the graph. So what I said, this is the velocity time graph where velocity is along y-axis, time is along x-axis. If the body is moving with uniform positive acceleration, the nature of the graph is something like this. Next, if the body is moving with uniform negative acceleration, so uniform negative acceleration, students, we can denote this uniform negative acceleration as something like this. So this is what? Negative acceleration. Okay. Then we can take for, in case of distance time graph also. So this is what velocity time graph. If I take position time graph or distance time graph, then uniform positive acceleration, in that case it is given by. So in that case it is given by something like this. This is what uniform positive acceleration for position time graph. Velocity time graph I showed you. Then next, if it is a acceleration time graph, if it is a acceleration time graph, then if it is a uniform positive acceleration, the nature of the graph is something like this. Okay. So for negative acceleration, uniform negative acceleration, so for this is what velocity time graph for this one negative acceleration. I'll show you for this one position time graph. The nature of the graph is something like this. This is for position time graph, negative acceleration. Then next, acceleration time graph. So acceleration time graph for negative acceleration, it will come somewhere here. So these are the different types of graphs for different object. So not only for uniform acceleration and uniform negative acceleration, we have the graph for body at rest, body is in uniform motion, right? So like that we can see here. So suppose if you say the body is at rest, then the nature of the graph for velocity time graph, it is parallel to the x-axis. This is velocity time graph. If the body is in uniform motion, then this is the nature of the graph for velocity time graph. So like this, we can show many graphs for different position of the body. So what is the use of this graph here, students? The graph will help you to calculate in that instant of time what is the position of the body, that we can determine by using the velocity time graph, position time graph, or acceleration time graph. Okay. Right. So you might have seen while watching the cricket match, you can see the graph here. They will show the run rate. So by that you will understand for a particular person, for a particular batsman, what is the run rate and all by understanding the nature of the graph. Similarly, we can understand the motion also with the help of graph here, right? Then, so what is equation of motion? So I told you in the beginning only, this equation of motion is nothing but it will relate the terms. It will relate the terms like the initial velocity u after time t and final velocity v, which is the final velocity. Then the acceleration a and the distance traveled in time is t. So these are the terms which it will relate. Right. Next. So this is called as what? Equation of motion for a uniformly accelerated body. The equations are, so first equation we have v is equal to u plus at. Second equation is s is equal to ut plus half at square. Third equation is v square is equal to u square plus 2as. So this we can show with the help of a velocity time graph. That is, so here we take uniform positive acceleration graph. Okay. So the graph is something looking like this. So this is time along x-axis, velocity along y-axis. This is u, and here this is theta. Okay. So I can name this figure as 0, then here D, C point, B point, A point. We can name it like this. Okay, you can name A here also. Anyhow, you can take. You can see here, this is what this O to A distance, or O to, here I'll name it as A, here I'll take it as E, right? O to A distance. So here O to A is equal to its initial velocity U. In the figure, BD is equal to final velocity is B. Then change in velocity BC can be written as it is BD minus DC. So what is BD value? BD value is final velocity V minus DC value. So this DC value is initial velocity U. So it is V minus U is the change in velocity. V minus U is what? Change in velocity. Okay, that is your BC value. Therefore, acceleration is equal to, how we define? Acceleration is nothing but it is slope of VT graph. It is slope of VT graph. So that is nothing but, so from the figure, the slope is given by, that is BC divided by AC, that is equal to, so BC value just now we saw, it is V minus U, AC value is T, therefore we are getting the equation A is equal to V minus U divided by T. See here students, we can rearrange this term. So if I want acceleration, I can use this formula. If I want final velocity, I can rearrange it as A into T is equal to V minus U, or final velocity V is equal to U plus AT. This minus U I'll transfer, it becomes plus U plus AT. This is what final velocity is equal to. Next, I can use this equation for calculating initial velocity also. So initial velocity is equal to, it becomes V minus AT. So time also I can calculate by using this. So time equation is written as time t is equal to V minus U divided by A. So like this, we can use many forms of this first equation of motion. V is equal to U plus AT. Getting? So this is how we can derive the first equation. Then similarly, we can calculate the second equation with the help of the first equation. That is S is equal to UT plus half AT square. So what we will do here to calculate S is equal to UT plus half AT square, we take the help of the distance traveled by the body is equal to area under OABD, area under OABD. So this area under OABD is given by area of triangle plus area of rectangle. Substitute the area of triangle formula, half into base into height, plus rectangle is length into breadth. So just from the figure, if you substitute all the values, directly you will get the second equation, that is S is equal to UT plus half AT square. So this is how we derive second equation. Then similarly, we can derive the third equation. So to derive the third equation, we so in some books you can see area of trapezium they will use. In some books you can see that the previous derivation only, we just change the substitution part. Okay, so here we can take the area of trapezium is equal to, so area of trapezium, if you substitute the formula, it is sum of the parallel side. Sum of the parallel side is OA plus BD divided by 2 into the this one AC. So here if you substitute all the values by using the terms from the figure, you can get the answer or the equation V square is equal to U square plus 2A into S. So then one more formula we have, that is distance traveled in nth second. The distance traveled in nth second is given by, it is Sn is equal to U plus A by 2 into bracket Tn minus T. U plus A by 2 into bracket Tn minus T is what? Sn is equal to the equation, right? Then next, so here you can see, this is what equation of motion for a freely falling object. What do you mean by this? See here students, just now we have seen the three equations like V is equal to U plus AT, S is equal to UT plus half at square, then v square is equal to u square plus 2as. In this equation, what we can do, we can substitute the acceleration a is equal to as acceleration due to gravity as g when the object is falling freely. Okay, therefore the equation becomes v is equal to u plus gt, s is equal to ut plus half gt square, v square is equal to u square plus 2ags. In place of a, I have just substituted g, that is acceleration due to gravity. So this is when the ball is falling freely towards the earth. Suppose if the motion is opposite to the earth's gravitational force, suppose the motion of the body is opposite to the gravitational force, then the equation becomes v is equal to u minus gt, s is equal to ut minus half gt square, then v square is equal to u square minus 2gs. So these are the three equations when the object is going opposite to the acceleration due to gravity. Is it clear? So we will use all these formulas and we will solve the questions. Next question. When an object falls freely under the action of gravity, its velocity increases. See here, students, what we say, when the object is falling freely, its velocity increases and the velocity value of g is taken as positive, means when it is towards the earth. When an object is thrown up vertically upward, its velocity decreases and the value of g is taken as negative. Just now I told you, when you are throwing upward, it is taken as negative. When it is falling down, it is taken as positive. So when an object is dropped freely from the top of a tower and another object is projected horizontally from the same point, both will reach the ground at the same time. So in gravitation, we deal with this concept in detail, okay? So what they want to say is, when you drop some object freely, here what happens, from the same height, but the object mass is different. Here the both will reach the earth at the same time, or if you project it horizontally from the same point also, it will reach at the same time. Next point, a body is dropped from a tower of height h and it reaches after t second on earth from the same tower if two objects are thrown, one is upward, one is downward, with the same velocity u, and reach the earth's surface after t1 and t2 seconds respectively. Then the time calculation is given by root of t1 into t2. The time period calculation is given by root of t1 into t2. So students, these are the synopsis part from a motion in a straight line chapter. That is what all we discussed. What is motion, types of motion, the terms related to motion, and the difference between distance and displacement, scalar quantity, vector quantity, velocity and speed, then the types of velocity, types of speed. Then next we discussed about acceleration, then types of velocity and acceleration, its definition, then acceleration, types of acceleration, unit, dimensional formula, then equation of motion. So these are the contents of this chapter. Okay, so based on this, we will see some application based question as well as the direct questions. So let us start with the first question now. The first question is, that is, a man goes 10 meter towards north, then 20 meter towards east, then displacement is. So very nice question it is. Here what you need to calculate, the displacement. You need to calculate the displacement of a man who is going towards north 10 meter and east 20 meter. So let us calculate. So according to the question, just let us draw a diagram because we need to calculate the displacement. See here, this is what towards east, he is moving 20 meter, and towards north, he is moving 10 meter. Calculate the, what it is, calculate the displacement. So if you take east as x-axis, so suppose if you consider this as x-axis and north as given as y-axis, then displacement is equal to, so displacement is equal to, we take it as 20 into I plus 10 into J. So what is I and J here? I and J are the unit vector along x-axis is I, unit vector along the y-axis is J. Now, the magnitude of displacement. So here the magnitude of displacement is given by, it is under root of 20 square plus 10 square. That is equal to. So what is 20 square? It is 400 plus 100. That is 500. So 500 can be written as 500 can be written as. So it is root of 500, that is equal to root of 5 into 100. So that is nothing but 10 root 5. That is nothing but 10 root 5. So here the options are given in terms of decimals and all. Therefore 10 root 5, again we can simplify and we will get it as 22.5 meters. 22.5 meters. Therefore the correct option is option A. Understood this? See here what they have given. A man goes 10 meter towards north and then 20 meter towards east. So this arrow mark should come up. Okay. So here, that is he from this point, the man is moving from this point. So this is north first 10 meter, then towards east 20 meter. This is in this way. Okay. Then displacement we need to calculate. Suppose if you consider this as x and y axis, we can calculate the magnitude of displacement by using square root of x square plus y square formula. That is nothing but 22.5 meter is the answer. Option A is the correct option. Let us see this next question. Next question is, a body moves over 1/4 of a circular arc in a circle of radius r. A body moves over 1/4 of a circular arc in a circle of radius r. The magnitude of distance traveled and displacement will be respectively. How we can calculate? That is, so what they have said, a body moves 1/4 of a circular arc. So what I'll do, just for your understanding, we can draw one diagram here. So if you assume this as a circular path, this we can take it like this. So this is what one circular arc they have said. So this arc I'll consider, the length of arc I'll assume it as AB. Okay. So the radius they have given it as R. This origin path I'll take it as O. The magnitude of distance traveled and displacement will be. We need to calculate distance and displacement both. Let the particle starts from A to B. Let the particle starts from A to B. So when the particle starts from A to B, the displacement is given by. The displacement is given by, it is AB is equal to under root of R square plus R square. That is equal to, it becomes root of 2 R square. It becomes root of 2 R square. That is nothing but R root 2. That is nothing but R root 2 is what? AB value. It is what? AB value. So if you see the options, in options R root 2, we have only one, that is option A. So directly we can go for that. But to just once we will confirm the distance, displacement also. Let us confirm the distance also. Okay, this is displacement. R root 2 is what? Displacement. In the previous formula what we used, same formula we have used here. Then what they have mentioned here, distance is equal to, it is nothing but 1/4 of circumference. 1/4 of what? Circumference here. 1/4 of the circumference, that is equal to 2 pi r divided by 4. 1/4 as they have said, therefore it becomes 2 pi r divided by 4 is equal to, it is pi r divided by 2. It is pi r divided by 2. So the correct option is option A. Option A is the correct option here. So very interesting question. A body moves over 1/4 of a circular path. 1/4 of a circular path in a radius of r. The magnitude of distance traveled and displacement will be. So displacement is r root 2 and distance is what? That is pi r divided by 2. So the correct option is option A. Next question. A man walks on a straight road. A man walks on a straight road from his home to a market. Means from home to market he is traveling. It is 2.5 kilometer away with a speed of 5 kilometer per hour. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 kilometer per hour. The average speed of the man over the time interval of time 0 to 40 minutes, 0 to 40 minutes is equal to. So how to calculate the average speed? Okay, so how we can calculate? See here, the time taken in going to market. So time taken in going to market is 2.5 kilometer with a speed of 5 kilometer per hour. Therefore, here we need to calculate in terms of minute. Speed and distance they have given, time we need to calculate by that. Because to calculate the average speed, we require first time interval. Okay, students. So see here, the time taken to go to market, is equal to, it is 2.5 divided by 5. 2.5 divided by 5, that is equal to, so 2.5 divided by 5, it is how much? It is 1 divided by 2. So time taken is nothing but, it is speed divided distance divided by speed. So distance is 2.5, speed is 5, therefore it becomes 1/2 hour, because it is given in terms of kilometer and hour. So half hour means how much it is? It is nothing but 30 minutes. It is nothing but 30 minutes, right? As average speed interval 40 minutes, so remaining time for consideration of motion is 10 minutes. Okay, so what they have said, the time interval they have given it as what? 0 to 40 minutes. Therefore, the remaining time is how much it is? 10 minutes. The remaining time is 10 minutes. So distance in remaining 10 minutes is given by, distance traveled in remaining 10 minutes is given by, it is 7.5 speed into time is equal to, distance traveled is equal to 1.25 kilometer. It is 1.25 kilometer. Therefore, average speed is equal to distance traveled divided by time taken. So what is the distance traveled here? The distance traveled, it is given. So we first, from home to market, it is 2.5 plus, then next journey is 1.25 because the speed he increased. Then time is nothing but, it is 40 divided by 60. It is 40 divided by 60. That is nothing but, it is 45 divided by, it is 45 divided by 8. Answer is option D. Answer is option D, 45 divided by 8. kilometer per hour. 45 divided by 8 kilometer per hour is the answer. That is option D is the correct option. Average speed is equal to distance divided by time. Substitute distance, substitute time. That is 45 divided by 8 kilometer per hour. Option D is the correct option. Is it clear? Next question. That is, the motion of a particle is described by the equation x is equal to bt, where a is equal to 15 centimeter, b is equal to 3 centimeter. Its instantaneous velocity at time 3 second will be. So we need to calculate instantaneous velocity. Equation is given as x is equal to a plus bt. Okay, so first let us write the equation, that is x is equal to a plus bt actually it is given as x is equal to a plus bt square. Okay, not only bt, it is bt square. Here in the question you can make it as bt square. Then they have asked you to calculate the velocity. So velocity is nothing but what? Dx divided by dt. Am I right? That is equal to d divided by dt into bracket. X value is a plus bt square. A plus bt square. That is equal to. So differentiation of a is 0 plus bt square can be written as 2bt. Bt square can be written as 2b into t. What they have said, at t is equal to 3 seconds. At 3 is equal to 3 seconds, it becomes v is equal to 2 into b value is how much? It is also 3. T value is how much? It is also 3. That is equal to 3 into 3. It is 9. 9 into 2. 18. So answer is instantaneous velocity is given by 18 centimeter per second, as the options are B. Option B is the correct option. They have given A, B values as centimeters. Therefore, we need to take it as centimeter per second. And see here, students, A differentiation is 0. Therefore, it becomes 0 plus 2bt. A value we are not using only, as the A term becoming 0 after differentiation. B is equal to 3 centimeter. I have substituted 3 centimeter. T is equal to 3 centimeter. I have substituted T is equal to 3 centimeter. Therefore, V is equal to, it is 18 centimeter per second. Option B is the correct option. Is it clear? Next question. A train has a speed. A train has a speed of 60 kilometer per hour for the first 1 hour and 40 kilometer per hour for the next half hour. Its average speed in kilometer per hour is given by. How to do this one? A train is having a speed of 60 kilometer in the first 1 hour. So speed is 60 and time is 1 hour. Then next it is 40 for the next half hour. Then its average speed in kilometer per hour we need to calculate. that is distance traveled is equal to 60 into 1 plus 40 into 1 by 2 by 60 is the speed in the time interval of 1 hour. Then next 40 is the speed in the time interval of half hour. That is equal to 60 plus 20. That is nothing but 80 kilometer is the distance traveled. 80 kilometer is the distance traveled by the body. Okay, so how we did this? That is speed is equal to distance divided by time. Therefore, distance is equal to speed into time. Right? We need to calculate average speed in kilometer per hour. So, how to do the average speed? That is to calculate average speed, the total distance we have calculated now. We need total time also. So, total time I'll calculate first. Total time is equal to 1 hour plus half an hour. That is equal to 1 plus 1 by 2 is 3 by 2 hour. Why I am not changing any unit here? Because they have asked the question, means answer in terms of kilometer per hour itself. Therefore, I am keeping the kilometer as it is and time also in terms of hour as it is. Right? Therefore, average speed is equal to, therefore, average speed is equal to total distance traveled divided by total time taken is 3 by 2. So 80 into 2, 80 into 2 is 160, 160 by 3. It is 53.3 kilometer per hour. 53.3 kilometer per hour. That is option B is the correct option here. Option B is the correct option. See that. So first, to calculate average speed, we need to remember that we need total distance, we need total time. Total distance is 80 kilometer. Total time taken is 3 by 2 hour. So average speed is given by total distance traveled divided by total time, that is 53.3 kilometer per hour. Option B is the correct option. Next question. A car is moving on a straight road, covers 1/3 of the distance with 20 kilometer per hour. So a car is moving on a straight road. It is covering 1/3 of the distance with 20 kilometer per hour and rest with 60 kilometer per hour. The average speed. So again we need to calculate average speed. We require the time taken. We require the time taken calculation. That is, so if we take the distance is equal to, it is x, and time is equal to t1 plus t2. So here we can write it as what it is given. A car is moving on a straight road. It covers 1/3 of the distance. So distance, if I take it as x, 1/3 of the distance is written as x by 3, first journey. Then next, with a speed of 20 kilometer per hour plus, then rest with 60 kilometer per hour. So total is x, 1/2 is given x by 3. So therefore the remaining distance becomes how much? It is 2x divided by 3. That is divided by what? 60. I hope you are understanding this. What I did, time taken. So speed is equal to distance divided by time taken. Therefore time taken is equal to speed into distance. Speed is how much? Speed they have given it as, we need to transfer this, that is time taken is equal to distance divided by speed. So distance, if it is x, speed is 20. Then next distance divided by speed is 60. So first distance value they have given it as x by 3. Then the remaining becomes 2x by 3. So if I simplify this, it becomes 1 divided by 1 by 60 plus 2 divided by 1 by 80. So after simplification, okay, means x by 3 by 20, 2x by 3 by 60. So simplify everything, you will get 1 divided by 1 by 60 plus 2 divided by 1 by 80. Therefore, the answer is 36 kilometer per hour. 36 kilometer per hour. That is option D is the correct option. Option D is the correct option here. Okay. Let us see the next question. The relation 3t is equal to under root of 3x plus 6 describes the displacement of a particle in one direction where x is in meter and t is in second. The displacement when velocity is 0. Okay, we need to calculate the displacement when velocity is 0. So very nice question it is. See the simplification part. See here, the equation what they have given, it is given as 3t root of 3x plus 6. This is the equation what they have given. What I'll do, I need to calculate the x value, right? X is what? Displacement here. Therefore, x, keep the x term one side, other terms on the other side. So root of 3x is equal to 3t minus x, 3t minus x. So squaring on both the sides, you will get 3x is equal to 3t minus 6. 3x is equal to 3t minus 6. That is squaring on both the side. Here it becomes whole square. This is in the form of what is a minus b whole square. It is a square plus b square minus 2ab plus a square plus b square minus 2ab. So a square is how much? It is 3t whole square. So 3t whole square is becoming 9t square minus plus b square is 36 minus 2ab, 2 into a into b is equal to 9t square plus 36 minus. So 3 2s are 6, 6 6 are 36 into t. So now what we can take here common? I can take 3 common. Can you see here? So if I take 3 common inside the bracket, we are left with 3t square plus 12 minus 12t. Why I have taken 3 common here? Because I can cancel 3 on both the side. Therefore, I am left with x is equal to 3t square minus 12, plus 12 and minus 12 into t. This is what velocity is equal to, this is what x is equal to, we got the equation. What is velocity? Velocity is nothing but dx divided by dt. That is equal to d by dt of, what is velocity term? The x value, 3t square minus 12t plus 12. Simplify this one. So if you simplify, you are getting it as 60 minus 12. You are getting it as 60 minus 12. That is v is equal to, but what they have said in the question, the velocity is 0. Therefore, 60 minus, it is 60 minus 12. Therefore, t is equal to, therefore it implies t is equal to, it is 2 seconds. T is equal to 2 seconds. So when you take t is equal to 2 seconds, substitute t is equal to 2 in this equation. That is nothing but x is equal to we have 3t square plus 12 minus 12t. T is equal to 2. So 3 is equal to 2 is nothing but 2 square is 4 plus 12 minus 12 into 2. So if I simplify this, I am getting the answer as 0. I am getting the answer as 0. See here students, what I did. I have taken the equation 3t is equal to root 3x plus 6. This is our equation. So we need x is equal to. We need x is equal to, therefore squaring the equation on both the sides, it becomes 3x is equal to 3t minus 6 whole square. That is 9t square plus 36 minus 36t. This is what 3x is equal to. I can take 3 common and I can simplify for x is equal to. Therefore, it becomes x is equal to 3t square plus 12 minus 12t. Therefore, v is equal to dx by dt. So, x value just substitute. Then v is equal to, you will get 60 minus 12. As they have given in the question, the velocity is 0. Therefore, it becoming t is equal to 2. So, when t is equal to 2, it is becoming x is equal to 0. X is equal to 0, right? So this is what, this is the our answer, option D. Option D is the correct answer here. Next. A car accelerated from initial position and then returned at initial point. So a car is accelerated from initial position and then accelerated, return to initial point. Here what happens? Well, option A, velocity is 0 but speed increases. Option B, speed is 0 but velocity increases. Both increases, both decreases. See, the correct option is what they have said. That is a car moves from the initial point and return to the same point. Therefore, here what happens? Displacement becomes 0. So when displacement becomes 0, what happens to our velocity? Velocity becomes 0. So option B is what? Speed is 0. That is wrong. And velocity increases they have given. Option C, both increases it is given. Option D, it is given both decreases. But as it is returning to the same point, velocity is 0. So first half we proved of the option A. But speed increases, that we need to understand. See, when velocity is 0, we say that average velocity, the ratio of average velocity to average speed is less than or equal to 1. Therefore, the speed also increases. The correct option is option A. Option A is the correct option, right? Then our next question. The displacement of a particle, moving in a straight line is given by, so equation is given by S is equal to 2t square plus 2t plus 4, where is in meter and in second the acceleration of the particle. We need to calculate acceleration. They have given the displacement. As we know, acceleration is what? Rate of change of velocity. So let us write. We have the equation as S is equal to 2t square plus 2t plus 4 is equal to, that is ds divided by dt it is asked. Therefore, it becomes 4t plus 2. Next, this is what velocity is equal to. Acceleration is equal to dv by dt. This is what velocity. Now dv by dt. So it becomes 4t, or it becomes 4 only. Okay, it becomes 4 only. Therefore, the option is option B is the correct option. Option B is the correct option. That is, acceleration is what? 4. Here we need to remember the differentiation mainly in this chapter. Then the Next question and the last question of today's classes. The position x of a particle varies with the time t as x is equal to at square minus bt cube. The acceleration of the particle will be 0 at time t equal to. So what equation they have given? First you see that. First write the equation. Again we want acceleration itself. That is x is equal to at square. Sorry, I'll write here. That is x is equal to at square minus bt cube. V is equal to what? Dx divided by dt. That is equal to x is 2at minus 3bt square. This is V is equal to. We have acceleration A is equal to what? dv by dt. That is equal to 2a minus 6bt. What they have said, the acceleration of the particle is becoming 0. So when the acceleration is 0, 0 is equal to 2a minus 6b into t. We require time t is equal to. So simplify this equation. How we can simplify? That is 2a is equal to 6bt. Therefore, t is equal to 2a divided by 6b. 2 1s are 2 3s are, that is nothing but a divided by 3b is equal to t. So option C is the correct option here. Option C is the correct option. So students, what we did here, we have calculated the acceleration. So question is what? The position x of a particle varies with time t as tx is equal to t square minus bt cube. The acceleration of the particle will be 0, means a is equal to 0. So what is the expression for time? They have given displacement x is equal to. So differentiate, you will get velocity. Velocity is equal to, we are getting 2at minus 3bt square. Then next, acceleration is again differentiation of velocity. We will get 2a minus 6bt. Here acceleration is equal to 0, you substitute. That is 0 is equal to 2a minus 6bt. Therefore, time t is equal to a divided by 3b. So the correct option is option C is the correct option. Option C is the correct option. Okay. So we have completed the synopsis of motion on a straight line and we are done with the 10 questions. Then in the next class, let us continue with the further questions. Okay, students. So go through the video. You will understand the concepts. Thank you.